আমার স্লাইড কি দেখা যাচ্ছে?
Yes, sir.
ওকে। Okay, so in the last class, we started the cryptographic hash function. So for cryptographic hash function, we have started to look into specific cryptographic hash function, which is known as SHA, secured hash algorithm. And at the beginning, we studied what is hash function, what is a good hash function. Then here we have looked at the one-way property, and then the collision-free property, and then again we have repeated and those same properties here, the requirements of a hash function. So here, if you look at on the left side, then you will see that which is pre-image resistance, what is second pre-image resistance, and what is collision resistance. So these three are very close. So sometimes we get confused, but you have to remember that there is some well-defined distinction. Okay, so they are not same. And say for example, for the first one, here only the given hash value age, so nothing has been given, so I am giving you only the age. So the adversary or the attacker will have to find out y, so that hash of y is equal to h. So I am giving the digest, that is the hash value, and the attacker will find the message y such that hy is equal to h. So if the attacker is successful to find out that kind of y, okay, so if the attacker can find a value of y, so that hy is equal to h, then we will say that this is not a good hash function and this requirement has been violated. Okay, so then we will say that the one-way property requirement has been violated. So for any age, any given age, if the attacker can find the value of y, so that hy is equal to h. So that means in pre-image resistance, I am giving only the hash value of h, nothing else. And in the second pre-image, here for any given block x, it is computationally infeasible to find y. So that means here I am not giving any hash value. Here I am giving the message itself. So I am giving the first message, and the first message is, okay, just wait for a second. Okay, so in the second pre-image, this is quite different, because in the second pre-image, I am giving the first message x. I'm not giving any hash value. So I am giving the first message x, and the attacker will try to find out another message y, where y is not equal to x. This exclamatory sign means not equal to in set theory. So y is not equal to x, but hy is equal to hx. That means hash of x is equal to hash of y. So I am giving the first message, and the attacker is looking for another message y. So then this is called, if the attacker is successful to find that, then this is we conclude that this requirement has been violated. Okay, so this is not a good hash function, because this is not second pre-image resistant. So a good hash function will be first pre-image resistant, and also the or just pre-image resistant, and also it should be second pre-image resistant, and finally it should be collision resistant. So when this requirement will be violated, collision resistant, then when the in the third requirement I'm not giving anything. Okay, no hash value, no message, nothing is given. The attacker will find out a pair by himself. So the attacker will find out the whole pair. Attacker will find the x, attacker will also find y, and then hx will be equal to hy. And definitely here x and y, they are not equal. Okay, definitely it makes, it's a common sense, because if x is equal to y, then there is no point, then this is hx is always equal to hy. So if an adversary or an attacker is able to find out such a pair where x and y are different, but hx is equal to hy, then we will say that this is not collision resistant. Okay, and this requirement has been violated. So when these three things will happen, these three things will happen definitely if there is no pseudo randomness, and the hash function is biased, and if you find that most of the times the hash values fall into a specific domain. Okay, because say you have a specific part, say the upper half of the hash value or the lower half of the hash value. So for a good hash function, we have to satisfy these three requirements, then we will say that this is a good hash function. And at the same time, there should be efficiency, that means hx should be relatively easy to compute. Okay, but like, to finding out these three, if I want to violate these three, then these three will be hard problem. Hard problem means computationally infeasible, because remember that if we go for like billions of search, then this is always possible, that you will find that hy is equal to hx. This is possible. Okay, if we go through like a serious level of searching, say for example for a few hundred hours, then definitely this is possible. But we are saying that those are hard problem, and uh, calculating hx should be an easy problem relatively. So that then we will say that this is efficient. So when hx will be easy, hx will be easy if you perform bitwise operation, because bitwise and or xor rotate, all those are relatively easy to perform, because we can perform those operations in hardware. So keeping in mind all those requirements, then we started to look at SHA, that is secure hash algorithm. So here SHA was first, like here, this is we have some little bit of history, not that much important. The important part is we are going to study, I think, SHA 512. So SHA 512 means this is our column. Okay, so we are going to study this part. Here we can see that the message digest size is 512 bit. That means size of our h, the final hash, will be 512 bit, and message size should be less than 2 to the power 128 bit. So this is the length. Okay, 2 to the power 128 bit, and each block will be 1024 bit. So if we have more than 1024 bit, then we will see how we can find different blocks form a very long message. We will divide the long message into different blocks. So, and number of step is 80, number of word size is 64. So the algorithm takes as input a message with a maximum length of less than 2 to the power 128 bit. Okay, so remember that this is the length, maximum length of the message. So finally, it will produce an output of 512 bit. Why? Because we have already said here that the message digest is 512 bits. But how it works? It divides the whole message into different blocks, and each time it works on a block. So it completes the first block, then it moves to the second block, then it moves to the third block, and at the end of each block, it generates a 512-bit message. So the output of the last block is our final output. The output of the last block is our final output. So if we have 3 blocks, then we start computing the first block. So at the end of the first block, a 512-bit message digest is produced. So we use this 512-bit to calculate the second block. So at the end of second block, we generate another 512-bit message digest, and we use that 512-bit message digest to calculate the third block. And at the end of the third block, what we have, that is our final output. That is our final message digest. So the processing consists of 5 steps. So if we look at the steps, so this is the big picture here. This is SHA-512 overview. So consider that this is our message, and the length of the message is L bits. Okay, here L bits means how many bits we have in the message. Okay, say for example, the length of the message is 1000 bits, then L will be equal to 1000. So L means how many bits we have in the message. So it does not care whether this is a Word file or PDF file or exe file. It just considers everything as a very long stream of bits. Okay, whatever we have, it considers that this is a very long stream of bits, just 1-0 combination. And then if this L is not a multiplicand of 1024, if this L is not a multiplicand of 1024, what does it mean? Say for example, L is equal to 3000. Now my question is this a multiplicand of 1024? 3000 কি 1024 এর multiplicand?
No, sir.
No, sir.
Okay, then we have to convert it a multiplicand of 1024. So the closest multiplicand of 1024 is if we multiply 24 to 3, then 72, right? So the closest multiplicand is 3072, because 3072 is equal to 3 times 1024. Am I clear? So we have to add extra 72 bits. So those 72 bits are known as padding. So we have to add extra 72 bits. So whatever the message is, we have to convert that message to a multiplicand of 1024. So that's why this part is our padding, end of the message. So the padding starts with a 1, this one is here, and then all 0. কি বুঝা গেছে কি বলছি? আমাকে
Yes,
এটাকে
sir.
সব সময় 1024 এর মাল্টিপ্লিকেন্ট বানাতে হবে। সেটা করার জন্য আমি প্যাডিং অ্যাড করব। প্যাডিং হবে ফার্স্ট leading 1, then followed by all zeros. So this padding will make this message, so that means the message plus padding is equal to always, okay. Now I left a very small part. No, I did a mistake there. I'm sorry. What we have to do, okay, let me start again. I have a message, and always I have a 128 bit for writing L. At the end, this part is reserved. This 128 bit part is reserved at the end. And now the message length is a variable length. Message might be anything. So whatever message I have, consider that this message is L bits. So what you have to do, you have to add L plus 128. Then you have to see whether L plus 128 is a multiplicand of 1024. So L plus 128. So message say consider that our L is 3000. So you have to add 3000 plus 128. So that is 3128. So that part is mandatory. Okay. এটাকে আমরা কোনোভাবেই চেঞ্জ করতে পারবো না। এখন আমার যেটা টার্গেট হবে সেটা হচ্ছে যে এই জিনিসটাকে 1024 এর মাল্টিপ্লিকেন্ট বানানো। সো 3128 3128 এটা কোথা থেকে পেলাম? 3000 is my message length. I have just assumed, this is my assumption, that my message length is 3000, and this 128 is fixed. I cannot change that 128. So 3000 plus 128, that means 3128. But this is not a multiplicand of 1024. Why 1024? Because at the end of adding this padding, at the end, that means message, then padding, then L, everything should be multiplicand of 1024. পুরা জিনিসটা মিলায় আমাকে একটা 1024 এর মাল্টিপ্লিকেন্ট বানাতে হবে। So this 3128 plus, say you are adding, say x is equal to the length of the padding. So 3128 plus x should be some multiplicand of 1024. Okay, so definitely what will be the value of n here? n এর সবচেয়ে ছোট ভ্যালু কি হতে পারে এখানে?
Sir, 4.
4. So then please tell me what is the value of x?
Sir, এটা হচ্ছে 968.
96.
Okay, give me 1 second. Let me
4096.
না, এক্সট্রা অ্যাড করতে হবে 968 x এর ভ্যালু।
x এর ভ্যালু জানতে চাইছি আমি।
968.
968. So here the minimum value of n is equal to 4. Minimum value, okay? So minimum value of n is equal to 4. So from there we can find x is equal to 900. Can you repeat again, Muna, please? 900?
Sir, 968.
968. So we have to add a padding of 968 bits. Any question from anyone? আচ্ছা একবার বলি আমি। For example, I have given you a message of L of 3000 bits. So my final target is make everything a multiplicand of 1024. Why 1024? Because you can see in the bottom that every step your length is 1024. We have also mentioned it here, right? The input is processed in 1024 bit blocks. So every block is 1024. Now I must keep that n as small as possible. Definitely I'm not going to like extend it unnecessarily. So my target is to keep n as small as possible. So here, if message is equal to 3000, then the last part, that is L, which is 128 bits, this is defined in the specification of SHA-512. I cannot change it. So worldwide, everywhere, if you are using SHA-512, then the length of L is 128 bits. That means I have given you a space of 128 bits to write the length of the message. So this is 128 bits, and I have considered my message is 3000 bit. So that means I have 3128 bits. This is already given. This part is fixed. I cannot change it. 3000 plus 128. Now I'm considering that my padding length is x. So ultimately this will be n times 1024. So I can easily see, it's very simple, right? I can find that the minimum value of n should be 4. So from there, if I put the value of n is equal to 4, then x is equal to 968. So what will be the combination of that 968? That 968 bit will start with a 1. There should be a leading 1, and then the rest of the part will be 0. Again, this is part of the specification of SHA-512. They have already specified everything. So আমাদের খুব বেশি কিছু করার নাই. Now, my question is, okay, কোনো question আছে?
স্যার x এর ভ্যালুটা হলো যেটা আমি প্যাডিং ইউজ করব সেই প্যাডিং এর ভ্যালুটা,
প্যাডিং এর
লেন্থটা। জি স্যার।
হ্যাঁ, আর প্যাডিং এর ভ্যালু হচ্ছে অলরেডি গিভেন, একটা 1 থাকবে, তারপরে সব 0 হবে।
স্যার তাহলে এটা 968 কে রিপ্রেজেন্ট করবে কিভাবে?
968 কে রিপ্রেজেন্ট করবে না তো। ও মানে প্যাডিং এর লেংথ আমি এখানে কত অ্যাড করলাম সেটা?
ইয়েস স্যার।
এটা করার তো দরকার নাই, তার কারণ হচ্ছে ওকে, হার কোয়েশ্চেন ইজ where I have written the value 968, right? That is your question.
Yes sir.
Okay, that's not required because as a receiver point of view, you will receive two things. You will receive the whole message and you will receive L. Okay, so you know the length of the message at the beginning at the receiver side. So what you will do, you will start generating the hash, right? So and you also know that this must be a multiplicand of 1024. So from these two values you can find out the length of the padding. আমি যদি টোটাল লেংথটা জানি, টোটাল লেংথটা আমি এমনিই পাবো, এটা তো অন্যভাবেই পাওয়ার কথা। But definitely there is a starting point and there is an end point of a message in every message.
Yes sir.
So at the receiver side, I will start calculating M1, hash of M1, then M2, then M3. So finally, after finishing the last hash code, then I'm sure, okay, there is no problem, right? So I want to receive this message. So I know the length of the total message because L is length of the message, and I know the length of everything at the beginning. So from there I can find out which part is message and which part is padding. Padding এর length তো আমার explicitly আর পাঠানোর দরকার নেই, সেটা বলতে যাচ্ছি আমি আর কি।
স্যার তাহলে প্যাডিং এর ভ্যালুটা কি একদম মানে ফিক্স থাকবে, সেম থাকবে? এখানে যেটা অ্যাড করতেছি 1, তারপর আদার দেন পরেরগুলো 0,
মানে এই 1 0 কম্বিনেশনটা, হ্যাঁ এটা ফিক্স।
হ্যাঁ, মানে প্রথম ভ্যালুটা 1 হবে, ওর পরের ভ্যালুগুলো সব 0 হবে।
সব 0 হবে, এক্স্যাক্টলি। দ্য ফার্স্ট
স্যার
ওয়ান উইল বি,
এইটার কি কোনো ফিক্সড লেন্থ আছে, মানে 1 এর পর কতগুলো 0 হবে?
no, it will come from the length of x. So
length of x.
If length of x is 968, so there will be 967 zeros.
এইটাই স্যার জিজ্ঞেস করতেছিলাম।
Okay, now my another question is, that is not my question. My question is, just remember that this is a very common practice in networking. I repeated the same thing in the last class, that in networking, the most important part is any kind of protocol. In any specification of the protocol, the most important part is header. Okay, always remember that. The most important part is header. So if I want to explain IP version 4, what I have to do, I have to explain you every tiny bits of IP version 4. Okay, and in a header of any protocol, every bit has some responsibility. Okay, even a single bit, maybe this is a flag, this is 0 means something, this is 1 means something else. So everything is defined in the header of the protocol. So here we have said that I am giving you 128 bits to write the length. Okay, say for example, if I give you only 4 bits to write the length, then in 4 bits, 4 bits mean you have only 4 places, right? You have just 4 places to write 10. Then in 4 bits, what is the maximum value you can write?
4 1
4 ones, and 4 ones means 15.
15.
Okay, so if I give you only 4 bits to write some length, then the maximum allowable length of that something will be 15. Because I have given you 4 bits to write the length, and you cannot write any value more than 15. So the maximum length I will allow for that message is 15. Am I clear now?
Yes, sir.
Okay, so if I give you a space to write a length, and that space is always fixed, okay, so the maximum value you can write on that space is the maximum allowable size of that message. So that's why here I have given you 128 bits. So the maximum value you can write here will be all ones. So all ones means 128 ones. So if I write 128 ones, what will be the minimum value here? The minimum value will be 0. And what will be the maximum value? The maximum value will be 228, 2 to the power 128 minus 1. That's why they have written these things, okay? That the message size, the maximum message size is less than 2 to the power 128. Okay, so here you can easily understand that in SHA-256, what is the length of L?
64.
64. So if you look at the specification of SHA-256, you will find that 64 bits have been given to write down the length of the message, because this is an old specification, and at that time we did not have that much bandwidth. So it's at that time it was enough that the maximum message length will be 256, 2 to the power 64 bits. But now they have increased it to 2 to the power 120 bit, and this is a very long message, remember that. But even then we have some limitations. We cannot send arbitrarily like whatever message I want. This is the maximum length. And what is the minimum? There is no minimum. Okay, if you want, you can even send a single bit. Definitely that will not be a good idea. And they have said that the longer the message is, the better like it performs. So it is also said that you should not send a very small message, because if you send a very small message, then the problem will be you have less number of M. Okay, because here when the message length is n times 1024, that means there is M1, then M2, and it's up to Mn. So you do the same calculation. Okay, here remember that I do the same calculation. If you look at the bottom part here, you will find that you are calculating the same thing. It is going through some f function, okay, and then it is going through some XOR function, and now it is generating h1, and that h1 is being used as the input of next f function. Okay, so if I have only, say for example here, my n is equal to 4, so that means I have 4 blocks, right? M1, then up to M4. In fact, I have 5 blocks. M1 is the initial block I have. So, no, sorry, I have 4 blocks. M1 is the initial block. So I have 4 blocks. M1, then M2, then M3, then M4. So I will do the same repetition, that is H1, then H2, then H3, then H4. And the final output of M4 will be H4, and that H4 will be my final message digest. So if I have very small number of M, that means very small number of blocks, then I do this calculation only maybe 2 times or 3 times. So this is not a very good idea. So they recommended that the message size, it should be like at least a few thousand blocks, so that you can do this calculation 4 times, 5 times, 6 times. Then it will give you better result. So how it works? At the beginning, we have some IV. Okay, maybe we can go forward. Let's start with step 1. So step 1 is the append padding bits. So I think I have already explained this part. So the message is padded so that its length is congruent of 896 modulo 1024. They have explained the same thing but in a difficult way. So where they are coming from, why this is 896? 896 is equal to 1024 minus 128. Okay, so what they are saying is same what we have explained here. We have said that after adding the pad, that means after the padding has been added, this length will be a multiplicand of 1024. A multiplicand of 1024 means the modulo 1024 will be 0, right? এখানে যদি আমরা মড করি 1024 দিয়ে, তাহলে আমরা 0 পাবো, কোনো হচ্ছে গিয়ে রিমাইন্ডার থাকবে না। সেটাই এখানে আসলে বলছে যে congruent to 896 modulo 1024. So padding is always added even if the message is already of the desired length. That means what they have said, that if this is a multiplicand of 1024, you will add 1 padding. Okay, you will add 1 block of padding. This is what they have said. Thus, the number of padding bits is in the range of 1 to 1024. So the padding consists of a single 1 bit followed by the necessary number of 0 bits. So after padding has been added, then we have M1, then M2, and then up to Mn. So this is my step 1. So step 1 is you have to append the padding bits. And remember that I made a mistake here again. Remember the bullet 2, they have said padding is always added. Okay, আমি এই কোর্স পড়াইছি মনে হয় 1.5-2 বছর আগে, around 2 years back সম্ভবত, এখানে আমি ভুলে গেছি। আচ্ছা, so padding is always added, remember that, even the message is already of the desired length. Now step 2 is append the length. So when the padding has been added, now you have message, you have padding, now you have to add the length. So what they have said, they have said that a block of 128 bits is appended. Now remember that it means you have to write the length in 128 bits. Say for example your length is 15. So 15 means you have only 4 ones. right? 15 মানে কি? 15 মানে just chapter 1, but this must be in 128 bits, so you have to add all zeros হবে, এটি আর কি এখানে বলছে। then we have to add all zeros here, okay, 0 add করে আমি এটাকে 128 bit বানাবো। bit integer unsigned means when you write only the positive numbers, unsigned মানে যেখানে কোনো নেগেটিভ নাম্বার থাকে না, so everything is allocated for writing the number. In signed number we use some of the bits to represent whether this is a positive number or a negative number. So unsigned এই জিনিসগুলো থাকে না, unsigned means normal regular numbers but only positive numbers. Okay, so the outcome of the first two steps yields a message that is an integer multiple of 1024 bits in length. So the total length of the message is now n times 1024. So step 3 is we have to initialize the hash buffer. So what is that hash buffer? Here, if you look at the first H0, so H0 is IV. Okay, IV stands for initialization vector, I think. So what we are going to do, we are going to assign H0 to IV. So this is fixed. Remember that in the specification they have given this pattern. এটা বলে দেওয়া আছে একটা 512 বিটস এর একটা ফিক্সড প্যাটার্ন আছে এখানে IV হিসাবে। So that IV will be one of the inputs of this f function. Okay, look, we are using it in two places, as one of the inputs of the f function and also in XOR. Okay, so for this f function, how many inputs we have? f function এর কয়টা input?
স্যার দুইটা।
দুইটা। One input is IV and the length of IV is 512. And what about the other input? What is the length of the other input?
1024.
1024. So we have two types of input. Here we have 1024 bits and the other input is 512 bits. And the final output will be 512 because we are doing XOR operation. নিচে এসে আমরা আবার XOR করতেছি, তাহলে এখানে একটা 512, এখানে হচ্ছে গিয়ে লেফট সাইডে another 512. So what is IV? This is initialization hash buffer. A 512 bit buffer is used to hold intermediate and final results. So here we are using from A to H. So we have 8 buffers, and if you look carefully you will find that all are hexadecimal numbers, and we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. We have 16 hexadecimal numbers. So each buffer here, each buffer is length of 64 bits, right? 16টা hexadecimal number মানে হচ্ছে each hexadecimal number you need 4 bits. So each buffer, you have 8 buffers and all of them are 64 bit. So if you multiply 64 times 8, then you can find that this is equal to 512. Okay, so this is equal to 512. So this A to H, you can consider, if you just consider that this is one kind of programming, then your A to H, they are some variables, and for the whole calculation they will always hold the value of this register. Okay, so just আমি যদি মনে করি যে আমার A থেকে H পর্যন্ত I have 8 registers and all the registers their length is 64 bits, so they will always, and they will be used repeatedly. If we move to a step 4, then it will be clear what I am saying. So these are the initial values. So this is the starting value of A, and similarly this is the starting value of h. So finally, at the end of all blocks, when you have finished calculating the value of mn, then you will find that you have finally you will be ended up with some values in A to H, and those values will be the final output of SHA 250 SHA 512. সো আমরা যেটা করব, আমরা একদম ইনিশিয়ালি এ থেকে এইচ পর্যন্ত এই ভ্যালুগুলোকে ফিক্সড, এগুলোকে অ্যাসাইন করে দিব, এবং এই এ থেকে এইচ রেজিস্টার গুলাই রিপিটেডলি ইউজ হবে আমার প্রত্যেকটা এম এর ভিতরে. সো দ্যাট মিনস when you are in f function you are using, and finally here the output, here you will, this output will come inside A to H. Similarly, here the output will come through A to H. So whatever you have after calculation of Hn in your A to H, that is your final output. তার মানে at the end of every block calculation you will have 512 bits in your A to H registers. Okay, so those same values you are going to use to calculate M2. So that means I have just a single copy of code, and that single copy of code is being used to calculate in every block. এবং ওই কোডের ভিতরেও আমার A থেকে H এই রেজিস্টারগুলো আছে, এই কারণে এখানে বলছে যে আমার A থেকে H এই রেজিস্টারগুলো আমি ইউজ করতেছি. So these are the just initial values. So you will just start the program with these values, and at the end of the program, whatever value you have in your A to H, that will be your final output. So this is your step 4, and this is where we calculate messages in 1024 bit blocks. So this is representing the calculation of a single block. Okay, এই পুরা পার্টটা হচ্ছে একটা সিঙ্গেল ব্লকের ক্যালকুলেশন, just the calculation of a single block, this whole part. So here I have mi and I have hi minus 1. So what is my mi? What is the length of mi?
1024.
1024. If you look at here, mi means m1, m2 up to mn. So I is the suffix here. I represents from 1 to n. So this mi is 1024 bits. এই পয়েন্টারটা এত ছোট, এটা খালি আমি হারাই ফেলি. Okay, so this is 1024 bits. And what is the length of hi minus 1?
512 bits.
512 bits. Similarly, the length of hi at the bottom is another 512 bits. So always remember, h means 8 registers from A to H. Okay, a capital H মানে হচ্ছে আমার 8টা রেজিস্টার, small letter A to small letter H. And every register from small a to small h, the length of every register is 64 bits. So 8 times 64 is equal to 512. So the same hi minus 1 is being used here. Look there, there is another branch, right? The same value is being used here in the XOR function. So if you remember, we have two parts, right? The first part is f function, and then the output of f function, that means these values will be XORed with hi minus 1. Okay, so here I have that hi minus 1. So these plus signs mean XOR. আমাদের নিচে যে প্লাস সাইন গুলো আছে, এই প্লাস সাইন গুলো রিপ্রেজেন্ট করতেছে XOR কে. So I have two part. One is f function and another one is XOR. So finally I have my output in HI. So your f function has two inputs. One input is mi, which is length of 1024 bits. Another input is hi minus 1, which has length of 512 bits. Now here, if we go back, you will find that we have mentioned 80, the number 80 somewhere here. We have said that number of steps is equal to 80. So this number of steps means number of steps inside f function. And word size means word size is equal to 64. Word size means the length of the register. We have 8 registers and length of each register is 64 bits. So এখানে word size বলতে আসলে ওই সাইজটাকে বোঝানো হয়েছে. So now if we go back there, any question?
So how about the number of steps?
The number of steps means inside the f function, if you go inside the f function, you can see that it starts with W0 and finally it's ended up at W79. So this part is one step. This part is another step. So in this way, I have in total 80 steps. And what do I do in a step? I do the same thing. In every step, I have round 0, then round t, then round 79. But inside this round, I do actually the same thing. Okay, I do the same thing, but the inputs and the outputs definitely will be changed. Input output change হয়ে যাবে. What I'm going to do here, I start with register A to register H, then the output of the round function will be also assigned inside the same registers. So from A to H, এই কথাই বলতে চেয়েছিলাম যে we are using the same registers repeatedly. So why I'm using registers? Because registers are way beyond faster than using variables, right? Because if you define a variable, that value will be inside your RAM, and when you will go to some calculation, you need some register will come to your RAM, the value will be transferred from the RAM to register, it will go to calculation, and again the output will be written to a register, that register will write down the value to the RAM. So if you deal with the registers directly, then your program will be way beyond faster than dealing with variables. Okay, so that's why they have mentioned that you are using some registers. Now, so we have almost explained everything. We have not explained few details, and I'm afraid we are not going to discuss those details. The thing is, we are not going to discuss what do we have inside this round function, because this is another very complicated means too many steps, and those XOR and those things inside the round function. I think it is in the book, or definitely we can find it in the internet, but I'm not going to explain that detail, because we have already explained what do we have inside the DES. So you can understand what it might be, something like that. DES এর মতো একটা কিছু. So what we are going to do, this 1024 message will be divided into 80 pieces. So we have W0 to W79. So that means, and we know that 1024 is not divisible by 80, right? So this is not that much straightforward. I'm dividing it into 80 pieces. Definitely they have some mechanisms to do this division. যে কিভাবে করে W0 থেকে W79 divide করে বের করা যাবে. This is one part. And another part is that we have not explained yet this key. Okay, So if you look at every round, you will find that we are using separate keys. So that means definitely we have some kind of root key or mother key, whatever you say, or pre-shared secret or something like that. And from that key, we have some key schedule algorithm, key scheduling algorithm, you can say. And that using that algorithm, we can generate different keys in every steps. You can also relate this with DES, right? সেখানে আমরা করছিলাম না, আমরা সাব কি জেনারেট করছিলাম প্রত্যেক স্টেপে আলাদা আলাদা। Same thing here, we are calculating different sub keys from key 0 to key 79. Now you can understand that why this is also called keyed hash, right? এই ওয়ার্ডটা আমরা আগে একটা জায়গাতে ইউজ করছিলাম, কোন একটা জায়গাতে আমরা বলছিলাম keyed hash function, right? Keyed hash function. And in the last class, we have said that this is different from generating the hash only, because in the hash only, there is no use of key. Okay, in hash only, you just take the message and you have different steps and you generate. Maybe there are some round functions also, there are some XORs and all those things, XOR, rotate, and those things, and you generate the digest only. But here we have said that this is a message authentication code, so we need some shared key. So that's why this is known as keyed hash function. So inside the calculation of the hash, you just blend, you mix the use of that secret key. So if we go forward, now processing message into 1024-bit blocks, this is the heart of the algorithm. That means this part, this is the heart of the algorithm. Processing message in 1024-bit blocks, it consists of 80 round and updating a 512-bit buffer. What does it mean? It means at the end of each round here, you update the buffer, that means the register, from A to H, and that value will be used as the input of the next round. So finally at the end, you have here at the bottom, you have the output in A to H, and that will be the output of this round. Okay, and this will be used to calculate the next round. This is the way, and always they are using the same variables from A to H. So using a 64-bit value WT derived from the current message. So now we have the length of W. So here each W is 64-bit. Okay, but remember that we have 80 rounds. So 80 times 64 is not equal to 1024. Definitely we have some mechanism how we can do this calculation. So, and a round constant based on the cube root of first 80 prime numbers. This part I'm not sure what they are talking about, and I'm skipping that part. If we have to understand, then the thing is, we don't have to understand every tiny details, because definitely I'm not going to implement it in programming language, right? If I have to implement this in hardware or software, then definitely you must know what do you have inside this round. So we are skipping that detail only, that what do we have inside every round. ওই পার্টটা আমরা এখানে skip করে যাচ্ছি। Now each round takes as input the 512-bit buffer value from A to H. I think we have explained. Each round makes a use of 64-bit WT derived from the block. These values are derived using a message schedule. Yes, this is the part. So using this message schedule, you generate W0 to W79. Okay, so you have some algorithm. The constants provided a randomized set of 64-bit patterns which should eliminate any regularities in the input data. So the output of the 18th round is added to the input to the first round hi minus 1. Like what they are saying that this part, that this output, the final output will go to the next block processing. So here you can easily find what they are saying. Here H1 is the output. So we are using this one to the processing of the next block. So if I have very small size, message size is very small, then I have small number of blocks. Okay, so that is not acceptable. Acceptable. What I was saying, you can do that. Remember that SHA-512 will not prohibit you. But what they are saying, you need minimum number of blocks so that the output will be better. Final output, that is step 5. After all n1024 bit blocks have been processed, the output from the nth stage, that means the final stage, is 512 bit message digest. So the output of the nth block is your final output. So I have H0, this value I will give from the program, and this is fixed. And finally, I have Hn, this is my final output. So here they have given some padding example. This is a very small message. Say for example, your message is just A, B, C. So what is the ASCII code for A?
So 97.
97. Small letter A, 97. Okay, now let me remember what they have done here. Okay,
It's 97.
I think this is equal to 97, right? I'm not sure. মনে তো হচ্ছে না। এটা কত ভ্যালুটা?
Yes, it's 97, sir.
This is 97. Okay. So they have converted that, like they have considered that ABC are simple text. So A is one character, then B is another, C is another. So this is 97, then I guess 98, and then 99. So what is the length of your message? 8 plus 8 plus 8. So the length of message is 24. So you have 24 in your L, and if we go back to our simple equation here, so L is equal to 24. So 24 plus 128 here, then capital N will be equal to 1. So you can calculate the value of X. So from that calculation, you will find that your pad length is equal to 872. So your pattern will be like this. A very, like, this is ABC, this part up to this part, A, B, and C. And then all 0, all 0, all 0, and at the end they have 18. Okay, জাস্ট এটা এক্সাম্পল দিছে আর কি, যে কিভাবে করে ক্যালকুলেট করলে এবিসি থেকে এটা পাওয়া যায়। 18টা কোথা থেকে আসলো? 18 ইজ ইন হেক্সাডেসিমাল, সবগুলো ভ্যালু হচ্ছে এখানে হেক্সাডেসিমালে। সো 18 হেক্সাডেসিমাল ইজ ইকুয়াল টু অ্যাকচুয়ালি 24 ইন 10 বেস। 18টা কোথা থেকে আসলো? 18টা ছিল কি মেসেজ লেংথ, রাইট? সো 18 ইন হেক্সাডেসিমাল ইজ ইকুয়াল টু 24। 18 কে যদি কনভার্ট করেন 10 বেজে, তাহলে 24 পাবেন। তো ওই কারণে ওখানে হচ্ছে গিয়ে 18 লেখা হয়েছে। তো 24 ইন 10। Okay, so I think that's all. Okay, SHA-1 not yet broken, SHA-2 seems secure. Again, these are very old data, so don't rely on these statements, what they are saying here, because this is dated back to 2012 or something like that. So we should not rely on this. Okay, so that's all for our secured hash algorithm lecture. Okay, so if you don't have any question, I'm taking a break for 5 minutes. Then I'm coming back. Any question?
স্লাইডটা মেবি শেয়ার করা হয়েছে এরপরে
ও তাই নাকি? আচ্ছা ঠিক আছে।
জি স্যার স্লাইডটা
ওকে, I'm sorry, আমাকে আগে বললে আমি করে দিতাম, আমি করে দিচ্ছি।
Sir, I think this is not a very good question, but I want to ask that
Sure.
isn't this is kind of a private key encryption technique or symmetric encryption technique?
Okay, this is not, first of all, this is not encryption. Okay, because this is hash function. That means we are considering that I'm sending, I can, if I want, I can send the message in plain text, but along with the message, I will send the hash also. Okay, let me draw something. Say here the consideration is I have a message M, and with this message I will also send, okay, let us make it capital letter, I am also sending hash of message, but since this is a secured hash algorithm or keyed hash algorithm, when I'm calculating the hash, I am adding some key here, K. So now this is being sent. So I have the same key and I have also the same key. So if you consider that part, then you can say this is symmetric, because both should have the same key. Otherwise, they cannot generate K0 to K79. Okay, so maybe your question is coming from that point of view, that is this symmetric or asymmetric. So from that point of view, you can say this is kind of symmetric. Definitely, both should have the same key. আমি কি অ্যানসার করতে পারছি কোশ্চেন?
স্যার এটা তো আমরা ইন্টিগ্রিটির জন্য ইউজ করি না স্যার, মানে ইন্টিগ্রিটি চেক করার জন্য কি ইউজ করা হয় এটা?
Okay, we have already answered that question here, right? We can use it in different ways. So if you use only for like which one should I take? This one. So if you use only in this way, then this is only providing us integrity, right? So I have key here K, I have key here K. So what I have written here, this scenario, the last slide, okay, this scenario, it matches with B. That means it is providing us only integrity. এখানে আমি যেটা লিখছি সেটা ম্যাচ করে হচ্ছে ওইখানকার বি এর সাথে, তাহলে শুধুমাত্র ইন্টিগ্রিটি প্রোভাইড করে। ওকে, এনি আদার কোশ্চেন? ফার্স্ট যে কোশ্চেন করছিলেন তার অ্যানসার কি আমি দিছি?
স্যার আমার কোশ্চেনটা হচ্ছে এরকম যে আমরা তো সিমেট্রিক এবং অ্যাসিমেট্রিক এই দুই এনক্রিপশন কি দিয়ে এই সবগুলো করে ফেলতেছি, তাইলে আমার এই হ্যাশিং এর যে নতুন কনসেপ্টটা এইটা আমার কি কন্ট্রিবিউট করতেছে?
Okay, the answer is here, because hashing is providing me only integrity. I can check whether what the message I'm sending, if this is correct. That means if an attacker captured this thing, he cannot change the message. because if he changes the message, he will have to calculate the hash again, but he cannot generate the hash. Why? Because I have added a secret key inside. So what is the added value? The added value is, first of all, I don't need encryption all the time. Okay, don't think that encryption is the only solution, because encryption is providing me secrecy, but in some cases I don't need secrecy, but I need integrity. That means I want to make sure no one has changed the value during transmission. Or I am using a database and I want to make sure that nobody could change the value of the database overnight. Okay, so, and I don't want to encrypt that database. I want to keep the database open because maybe somebody else will use that database. তো আমি যদি এনক্রিপ্ট করে রেখে দিই সবকিছু, তাহলে তো কেউ সেটাকে ইউজ করতে পারবে না। আমি সবসময় সবকিছু এনক্রিপ্ট করতে চাই না। বুঝা গেছে কি বলছি?
Yes, sir.
Okay, so any other question?
স্যার এই মেকানিজম ইউজ করে কি ইন্টিগ্রিটি বাদে অন্য অথেন্টিকেশন বা এই টাইপের অন্য কোনো কিছু কি চেক করা সম্ভব?
এই যে সব কোশ্চেন আমরা এখানে আগে বলে আসছি তো, কি কি করা যায় কি কি করা যায় না। মানে definitely if you want to do something else in addition to integrity, then say for example here, if you want digital signature, then you need hash plus private public key. So for digital signature, for example, only private key public key is not enough. So then you need hash plus private key public key. Okay, so that is my answer. So don't think them like, for example, public key or hashing separately. Instead of that, think that we have studied two different mechanisms, but for a complete solution, we need both of them sometimes. Okay, শুধু একটা
জি স্যার,
দিয়ে আমার করা যাবে না, এটাই কি আমার অ্যানসারটা চিঠি আর কি। ওকে,
জি স্যার বুঝতে পেরেছি স্যার, থ্যাংক ইউ স্যার।
okay, so I'm coming back just 5 minutes and I will update the slide also. Okay, so give me your attendance first. After giving the attendance, I want to discuss about a very simple assignment. Okay, Raihan,
Present, sir.
Tauhid,
Present, sir.
Mahfuzul Islam,
Yes, sir.
Azwad, Azwad,
Present, sir.
Ryan,
Yes, sir.
Talha. I think he was here, right? Okay, Abdullah Suleiman,
Yes, sir.
Adnan Rashidul, Abid Hassan, Mazharul Haq, Sumaita,
Yes, sir.
Mustari,
Yes, sir.
Rafid,
Present, sir.
Afrin, Mominul Islam,
Yes, sir.
Said Abdullahi,
Yes, sir.
Raunok Abdullah,
Yes, sir.
Jannatun Naim,
Sir, present, sir.
okay, Salikin,
Present, sir.
Sajjadur Rahman,
Present, sir.
Sajjad Ahmed, Imtiaz Mahmud, Rubaiyat Salehin,
Present, sir.
Sayyidat Tabassum,
Present, sir.
Didarul Abedin,
Yes, sir.
Muhammad Jama,
Yes, sir.
Fahad Hassan, Zibril Adan,
Yes, sir. Present.
okay, Abdullahi Hassan,
Present, sir.
Nuzat Yasmin, Anik Chaudhary,
Yes, sir.
Ikramur Rahman, okay, Abdullahil Farooq. Anybody else? Okay. Okay. Now, so I want to give you a very simple assignment, and that is we have already I will send you an email like formulating everything what I'm saying now, because now I'm saying just in text. So I will write it down and send you an email. But let me explain first. So we have studied so far DES, data encryption standard. We have studied RSA, and we have studied SHA 512. So I want you to measure time complexity of these three cryptographic algorithms. So time complexity means you don't have to implement from the scratch. So you can use any kind of standard programming language, say either Python or C or Java, whatever programming language you want. And you have to find out the functions, because in Python and also I think in Java, I'm not sure about in C, these are already built in. So you will easily find built-in functions for DES, for RSA, and for SHA 512. So your task will be take three variable size of files or messages, whatever you say. So the first size will be 100 megabyte. The next one will be 500 megabyte, and the third one will be 1000 megabytes around. Okay, so it might be very little bit. So you can take zip files or whatever files you have. So then you have to encrypt using DES, and then you have to encrypt using DES, and also you have to decrypt using DES. So you will perform two things, encryption and decryption, and you will measure how much time is required for these three size of files. So definitely you need some encryption key. So you are free, you can like assign your own data encryption standard key. Okay, so whatever key you want to use, you can use. So you will, in the report, you will write what key you are using, what is the actual file size, and how much time it takes for three different size or three different files. Then you will come to RSA. So in RSA also you will write down in the report, you will mention what is your encryption key, that is what is the public key you are using, and what is the corresponding private key. And you will measure the encryption decryption time together. So you will encrypt and you will decrypt and you will measure the time. So then again in SHA-512 you will do the same thing, and you have to mention the time. Okay, and if for a small size file, say for 100 megabytes, if you cannot measure the time because maybe it is taking very small amount of time, then there is an old trick. The old trick is you will do the same thing, say for 100 times in a loop, and then you will measure the time it needs to do that 100 times. So you will divide that time by 100. So you will get the time needed to perform the task for one time. 100 বার করে 100 দিয়ে ভাগ করব, ভাগ করলে আমি পেয়ে যাব যে আমার একবার করতে কি পরিমাণ সময় লাগতেছে। Now, any question from your side? One by one. First of all, is this clear what I have said?
So that means we have to write three programs, the one for DES, RSA, and SHA, three different programs.
Exactly, but you don't have to write the details code of DES, RSA, and SHA. You can use any standard library.
Sir, should we include the source code of the programs?
Yes, exactly. Definitely. Yes, exactly. The code might be very small, maybe say 30 lines, 40 lines, because if you use the standard library, then the code will be very small, I know, but that small code you have to include in the report.
So we can also allow to choose any files. It can be video file or Word or any PDF file, say 10 megabytes.
Any files, 100 megabytes, 500 megabytes, and 1000 megabytes. Any files. But just you in your report, you have to mention what types of file you have selected.
So এটা কি ইন্ডিভিজুয়ালি করব সবাই নাকি?
এটা ইন্ডিভিজুয়ালি, হ্যাঁ, না ইন্ডিভিজুয়ালি। ইটস এ ভেরি স্মল প্রজেক্ট।
আচ্ছা,
ওকে, মানে কারো একটু সময় লাগতে পারে, হয়তো এই মুহূর্তে আমি প্রোগ্রামিং এ আমি অত এক্সপার্ট না, বাট আই থিংক উইথ মিনিমাম স্কিল ইউ ক্যান ডু দ্যাট, বাট ইট উইল গিভ ইউ দ্য লাইক ভেরি গুড আন্ডারস্ট্যান্ডিং. I'm sure it will give you a very good understanding, like how this encryption or these things are being used. I know, I'm sure. Okay, আর এখনকার তো কেউ আর from the scratch এগুলো ইমপ্লিমেন্ট করে না. In fact, it's not required, right?
So what would be the submission deadline?
I will give you the deadline.
Sir, the three algorithms are this and RSA.
And SHA-512.
Sir, we should do encryption and decryption, right?
In case of DES and RSA, you will do both encryption and decryption. But in case of SHA-512, just calculate the hash. So how much time it takes to calculate the hash.
Now I get it.
Okay. And also in SHA-512, you can also mention in the report the output of the hash. Okay, because this is a very small output, so you can include that in the report.
Okay, sir.
So I will compose everything and I will send you by email, or I will upload in LMS. So then you can easily understand if you have any question. Okay.
স্যার একই প্রোগ্রামের ভিতরে কি এনক্রিপশন ডিক্রিপশন দুইটাই করব, তারপর টাইমটা ইয়ে করব, মেজার করব?
এক্স্যাক্টলি। মানে আমি টোটাল টাইমটা দেখতে যাচ্ছি যে এনক্রিপ্ট করতে ডিক্রিপ্ট করতে পুরোটা করতে কি পরিমাণ সময় লাগে, দ্য টোটাল টাইম ইউ নিড ফর
টোটাল রান টাইম।
ইয়েস।
ওকে,
যে কোনো ল্যাঙ্গুয়েজ ইউজ করা যাবে তাই না?
যে কোনো ল্যাঙ্গুয়েজ, whatever language you want. Even PHP is allowed if you want. Any kind of programming language. Say Python, I think Python will be the easiest way, or Java if you are comfortable with Java. Okay, so that will be our assignment, because we have some allocated marks for assignment, and I think it will be relatively easy for all of you. I'm expecting that. And if you face any difficulties in programming, then you can take help from any other, like your friends or anybody, or from internet. And these codes are, I think, already available. So I don't like, there is no problem if you even download the code and run in your machine. I don't have any problem. ওকে, এখানে কোডিং এর তেমন কিছু নাই। সো কোড যদি আপনি ডাউনলোড করে রান করেন আমার কোনো সমস্যা নেই, বাট ডেফিনেটলি দ্য ডেটা ফাইল দ্যাট ইউ আর গোয়িং টু এনক্রিপ্ট, দ্যাট শুড বি ইয়োর ওন ফাইল। দ্যাট ইজ মাই এক্সপেকটেশন, যে আমি আমার নিজের ফাইল এখানে হচ্ছে গিয়ে রান করাই, দেখবো জিনিসটা কি হয়। ওকে, so if you don't have any other question, that I'm now going to end the class. So next class we are going to start a new topic.
স্যার নেক্সট ক্লাস কি কোনো এক্সাম হবে স্যার?
না, নেক্সট ক্লাসে হবে না, যদি আমরা সব সেট করতে পারি তাহলে তারপরে ক্লাস একটা নিব।
ওকে স্যার, থ্যাংক ইউ স্যার।
থ্যাংক ইউ স্যার, আসসালামু আলাইকুম স্যার।
Okay, so I'm leaving now. Okay,
থ্যাংক ইউ স্যার, আসসালামু আলাইকুম।
welcome.
আসসালামু আলাইকুম।
Welcome.